So today we're going to be looking at fixing an iPad Pro 11 first gen. The screen came into us pretty beaten up, so looking at the damage, it's going to be a simple screen swap to get this device up and running. We'll also be swapping the LiDAR sensor assembly over to the new screen, which is attached and paired to your original screen. For safety reasons, before starting the repair, we recommend discharging the battery below 25%. This is to reduce the risk of fire if the battery is accidentally damaged during the repair. One thing to be aware of before starting this repair is that if you use an Apple Pencil with your iPad, the sensitivity will be affected by replacing the screen. The extent as to how much the pencil will be affected will vary depending on the quality and type of screen replacement you use. The general issues are that the pencil will become too sensitive, as well as the straight lines become wavy. However, there are certain apps where you can adjust the pencil sensitivity to improve the experience. Also, if you're unsure what tools or parts you need to complete this repair, follow the link in the description where you can purchase the exact parts and tools we're using throughout this guide. So to start the repair, you'll need to pry the screen off using a prying tool. Before you start prying, you're going to need to be aware of the delicate components that are underneath the screen. On the right hand side, you have two screen magnets, one at the top near the volume buttons and another at the bottom. You're going to want to make sure you only insert a prying tool no more than 2mm for these magnets and then no more than 5mm for the remainder of the right side. At the top, you've got the camera module, two ambient light sensors, the proximity sensor and the front microphone. You're going to want to avoid prying where the ambient light sensors sit to avoid damaging them, and when prying across the front camera module, don't insert the pick more than 1mm to avoid damaging the proximity sensor and front microphone. For the bottom, make sure you are prying no more than 5mm to avoid damaging the USB-C port. And lastly, along the left edge, you'll need to avoid several display cables that are located along small indents of the frame. For these indents, you'll need to insert your prying tool at a 45-degree angle at no more than 5mm to avoid damaging the cables. For the rest of the left side of the frame, you can pry horizontally as normal, inserting the prying tool no more than 5mm. It's worth noting that because our screen in this video is heavily damaged, we're able to remove the screen quickly and fairly easily as there are chunks of the outer screen already missing. However, if your screen is in a better condition, you're going to need to follow a more conservative approach to removing it. This would start by ideally heating the screen on a heat mat, or failing that, a hairdryer, to help loosen the adhesive holding the screen to the frame. Please note the screen should not be heated over 50 degrees. You can also use a suction cup to help lift the screen away from the frame if you're struggling to insert your prying tool. You can also use small amounts of IPA to help loosen the adhesive of the screen. Just make sure you only use a small amount, as using too much can damage the screen's backlight or internal components. Once you've got the screen loose, you'll be able to gently shift the screen towards the bottom right corner of the frame until you can see the ambient light sensor ribbon cable near the top edge. Now you can remove the ambient light sensor cable bracket using a Phillips 000 screwdriver to remove the two screws securing it down. You can then disconnect the sensor cable by lifting it out of its connector. Next, you'll need to flip the screen open like a book and remove the bottom cable shield by unscrewing the 3 Phillips screws. Now you can remove the single screw securing the battery connector to the logic board. To make sure the battery is definitely disconnected from the motherboard, insert a prying tool and some IPA to the motherboard and pry the motherboard up. You can then insert a thin prying tool like a prying card underneath the motherboard to keep it disconnected. You can now disconnect the 2 top display cables followed by the 2 bottom display cables. Once the cables are disconnected, you can safely remove the screen. Next, clean up the frame with IPA and a spudger and remove any remaining adhesive. If your new display didn't come with 2 display cables, follow the next few steps to remove these cables from your old display and transfer them into your new display. Start by separating the non-removable display cable from the bracket by folding it back. Then, using a Phillips 000 screwdriver, remove the 2 screws holding the bracket in place and then remove the bracket. You can then remove both of the display cables. Next, you're going to need to remove the LiDAR sensor assembly from your old display and transfer it to your new display. The LiDAR sensor assembly is paired to the Face ID hardware, so you'll need to transfer it to keep Face ID functionality. The LiDAR assembly comprises of 4 total sensors, including 2 ambient light sensors, 1 proximity sensor and 1 microphone. You need to separate each sensor from the screen before removing the entire assembly. Because our screen was heavily damaged, each of the sensors has already been removed from the display, so we're able to remove the assembly much faster than usual by peeling the assembly away from the screen. If you're struggling to remove it, make sure you're peeling carefully, and it may be helpful to use IPA and heat on the flex to help remove it. If you use IPA, please avoid getting it on any of the sensors. Next, you'll need to remove any leftover glass or debris from the screen that's still stuck to the LiDAR. We're using a blade to remove any glass parts from the sensor. Please be careful if using a blade to avoid damaging any cables or sensors. Next, you can connect the 2 display cables removed earlier to the new display, as well as fastening them down with the display cable bracket. Now you can connect the display cables and screw down the battery connector and test that the display is working before fully fitting the device. Make sure you test touch functionality until you're comfortable that it's working as it should. When connecting the cables to the device, ensure the battery is isolated with a battery isolation tool or plastic card to avoid damage to the motherboard. Once you're happy, you can disconnect the screen and fit the LiDAR assembly. Start by removing the plastic backing sheet on the new iPad display. Make sure you do this, as if you don't, your iPad will be more prone to overheating. Next, start aligning your sensor assembly to your replacement screen, and then peel back the pre-applied tester tape protector on the back of the display and secure the sensors. Continue peeling back the rest of the tester tape protector to begin fitting the display in the next steps. Next, refit the display cables and the bottom cable shield. Before fitting the screen into the housing, it's best practice to use tester primer on the frame of the housing. This will help bond the display to the housing to avoid future lifting. Next, you'll need to reconnect the ambient light sensor cable and cable bracket. Lastly, you can gently press the display into the housing to finish the fitment and apply a moderate amount of pressure across the outer edges of the display to help the tester tape bond to the housing. And that's it, your iPad has a brand new screen as well as working Face ID. I hope you found this guide useful. If you did, give this video a thumbs up and click the subscribe button if you want to see more repair content like this one.